Welcome. Today we are exploring GitHub Copilot. Our guide is the book Learning GitHub Copilot by Brent Laster. We're looking at how this AI tool changes the way developers work.
Indeed. Our goal is to break down Copilot's core features and its impact based on Laster's book. We'll go chapter by chapter, aiming for clarity for a technical audience, focusing on practical use.
Consider this a structured overview for using AI in your coding. We'll pull out the key information. We want to help you understand how to use Copilot effectively. Let's begin with the fundamentals. What exactly is GitHub Copilot? And how does this AI assistance function within a developer's typical environment?
Copilot is essentially an AI pair programmer. It integrates directly into your IDE, your integrated development environment. Its main purpose is to generate code. As you type or using your comments, it suggests code. This might be small snippets, complete lines, or even entire functions.
So it helps write code faster. That seems clear. What technology makes this possible? You mentioned AI. Does it use these large language models, the LLMs we hear about?
It does, yes. Copilot is powered by advanced large language models. These LLMs are trained on enormous data sets, huge amounts of code and text. This training allows them to recognize patterns and predict the most likely next piece of code. It's not just predicting words, it understands coding patterns and context.
That sounds very capable. But surely there are important points developers need to keep in mind. The book stresses checking Copilot's suggestions, for example.
Absolutely essential. Copilot uses context, your current code, other open files, but the developer, you, must always review and validate its suggestions. Laster's book points out potential issues, outdated information, incorrect details, these are called hallucinations. Or sometimes the code suggested might be incomplete. This often relates to the model's training data cutoff point.
So it's a very helpful assistant, but the developer remains in charge. How does Copilot differ from more general AI tools, perhaps like ChatGPT?
Copilot is specifically designed for coding. It lives inside your coding tools. Its training is focused on programming languages and practices. ChatGPT is broader, designed for many kinds of text generation. Copilot is specialized for software development.
And how does one get access to Copilot? Are there different versions or plans available?
Yes, there are several plans. Options include free, pro, pro plus, business, and enterprise tiers. These offer varying levels of access to features, different AI models, and they have different costs. Some advanced actions, like using sophisticated models in chat or agent mode, are termed premium requests. These have usage limits depending on your plan.
Now let's transition to actually using Copilot while coding. Chapter 2 discusses using it directly in the editor.
This is referred to as inline mode. It's where Copilot works alongside you as you type. It watches your code and comments, providing suggestions right there in the editor. These suggestions usually appear subtly. You can accept them fully, partially, or look at other options.
That sounds very integrated. And you mentioned comments earlier. They can actively guide Copilot.
Yes, comments are very important for directing Copilot. They're not just for humans anymore. You can write a comment like, say, #create a function to determine if a number is prime. Copilot will then understand your intention and suggest the code to implement that function.
That's a clear way to provide instructions. Can it also help with reviewing code for quality?
It can assist with code review. You can select code and ask Copilot to check for problems or suggest improvements. It might suggest adding documentation, point out potential bugs, or propose refactoring for clarity or efficiency. You can even provide custom rules to guide its review process, aligning it with team standards.
Helping maintain code quality is a definite plus. It can even help with Git commit messages.
That is correct. Copilot can analyze the changes you've staged for commit. Based on those changes, it will suggest a relevant and concise commit message. This helps streamline the version control process.
Moving beyond inline help, Chapter 3 covers Copilot's chat feature. This sounds more interactive.
It is indeed. Copilot Chat provides a conversational interface. You can ask questions in natural language and receive detailed explanations. This is particularly useful for understanding code you didn't write, or for learning about new libraries or concepts.
The book mentions different ways to use this chat functionality.
There's the main chat view, which is good for longer conversations. There's also an inline chat for quick questions right within your code, and quick chat for very brief temporary queries. Plus, there are / commands, like typing tests, which tell Copilot to perform specific tasks quickly.
To get the best results from chat, how can we ensure Copilot understands our specific needs?
Providing clear instructions is key. That's often called prompt engineering. You can also guide its focus using chat participants and chat variables. For example, at Workspace, tells it to consider your entire project context. At Terminal, focuses on recent command line activity. These help it narrow down the relevant information.
So we can direct its attention effectively. Can we manage different chat topics separately?
Yes, you can initiate multiple chat sessions. It's generally a good practice to start a new session for each distinct task or question. This prevents confusion and ensures Copilot's context remains relevant to the current discussion.
Chapter 4 introduces more advanced capabilities. Let's talk about next edit suggestions. What are they?
Next edit suggestions, or NES, try to predict your next coding step. If you make a change, say, modify a function signature in one place, NES might suggest corresponding changes needed elsewhere in your code, like updating calls to that function. It helps maintain consistency across related code sections.
So it anticipates the ripple effects of a change. What about Copilot edits?
Copilot edits allow for broader changes across multiple files. You give it a high-level instruction, for instance, add type hints to all functions in these files. Copilot will then attempt to apply that change systematically across the files you've selected. It's like an intelligent batch editing tool.
That could save considerable time on refactoring tasks. Agent mode sounds even more sophisticated.
Agent mode represents a step towards more autonomous operation. You provide Copilot with a goal, perhaps refactor this module for better performance. It then plans the steps, makes the code changes, potentially updates tests, and tries to verify the results. You still review and approve everything, but Copilot handles more of the execution sequence.
The chapter also mentions Copilot Vision. How does understanding images help a developer?
Copilot Vision allows the AI to process visual information. You could, for example, give it a screenshot of a user interface design. Copilot might then attempt to generate the code needed to build that UI. It can also explain diagrams or help debug based on images of error messages or code states.
So it adds another dimension to debugging beyond just text analysis.
Exactly. It enhances debugging. Copilot can help set up debug configurations, suggest fixes for errors it detects, and with Vision, it can analyze screenshots of problems, offering diagnostic insights based on visual context.
Let's discuss Chapter 5, Testing. This is often a time-intensive part of development. How does Copilot help here?
Copilot can significantly assist with testing. It can suggest testing strategies. More directly, it can generate test code. This includes unit tests for individual functions, and also integration tests, which check how different parts of your system work together.
How does it actually create these tests? Is it automatic?
You can prompt it using the tests command in chat, or you can write a comment in your code file, like #generate test cases for this function. Copilot will then suggest the test code. But crucially, you must review these generated tests carefully, just like any code it produces.
Can we guide it to test specific conditions, like unusual inputs or edge cases?
Yes, you can specifically ask for tests covering edge cases. For example, what happens with 0 null inputs or very large numbers. You can also instruct it to generate input validation checks to ensure functions handle incorrect data types gracefully.
What if our team has specific rules or frameworks for testing? Can Copilot adapt?
You can configure custom instructions for test generation. By providing rules, perhaps in a configuration file, you can guide Copilot to use your preferred testing libraries or adhere to specific formatting standards. This ensures the generated tests fit seamlessly into your existing testing practices.
It sounds versatile enough to support methodologies like test-driven development, too.
It certainly can support TDD. You could have Copilot generate the tests first, based on your requirements. Then, potentially using agent mode, you can task Copilot with writing the implementation code needed to make those tests pass.
Moving to Chapter 6, Documentation. This is vital but often neglected. Can Copilot assist?
Yes, Copilot is quite helpful for documentation tasks. It can generate comments within your code. You can ask it to explain what a function or block of code does. You can even request different levels of detail. For instance, asking it to verbosely comment this function will yield more detailed explanations.
So it handles the comments inside the code. What about other forms of documentation?
It can also help generate API documentation. If you have API definitions, it can produce documentation in formats like Swagger or OpenAPI. Additionally, it can assist in writing functional documentation, descriptions of how the software works, intended for end users or other stakeholders.
That external documentation capability is very useful. Beyond generating documentation, can it help us understand code?
Explaining code is definitely one of its strong suits. If you're learning a new language, it can outline differences from one you know. You can select complex code and ask for an explanation, or ask it to summarize the purpose of a large module or file.
Can it also explain potential problems or risks in the code?
It can try. You can ask it what might go wrong in this code. Copilot will analyze it and point out potential issues, like possibilities for errors or areas that might be fragile. It's like a quick, automated risk assessment.
And its helpfulness extends to the command line, too.
Yes, it can explain terminal commands. You can ask it about the last command you ran, or you can ask it how to perform a task, like how do I find files modified today? It will provide the command and explain it.
Chapter 7 addresses an important point, keeping Copilot's suggestions relevant and timely. Why might its answers be outdated or inaccurate sometimes?
This relates back to the LLM training. Copilot's knowledge is based on data available up to its last training date, its training cutoff. So it might not know about the very latest library versions or API changes. It might suggest deprecated functions. And as mentioned, it can sometimes generate plausible but incorrect information, those hallucinations. It doesn't fact-check in real time. Also, if you don't provide enough specific context, its answers might be too general to be useful for your particular situation.
So its knowledge isn't live or constantly updated from the internet.
That's correct. It operates based on the patterns and information learned during its training phase.
How can users help Copilot provide better, more current answers for their specific project?
Providing clear context is the most direct way. Use those chat participants, like at Workspace. Or use chat variables like #file to point it to specific files. This focuses its attention. Also, if your plan allows, sometimes switching to a newer underlying AI model might help, as newer models may have more recent training data.
What if the necessary information isn't in its base model, like details specific to our private code base or database?
You can provide that context directly. If you're working with a database, open the file containing your database schema in the editor. Copilot will then use that schema as context. When you ask it to write a query, it will use your actual table and field names. This makes its suggestions much more accurate and relevant to your specific project needs.
Chapter 8 explores less common but still valuable applications. What else can Copilot do?
Its abilities extend to areas like SQL database work. It can write complex queries. It can generate stored procedures, which are saved blocks of SQL code. And it can even suggest database indexes to potentially improve query performance based on your schema.
So it has a good grasp of database concepts. What about configurations for things like cloud infrastructure?
It handles declarative specifications well. Think of YAML files used for Kubernetes or Terraform configurations. You can ask it to generate a Kubernetes deployment YAML, for example. It can also help explain how to apply these configurations or even translate them into code for infrastructure management using SDKs.
Regular expressions are often tricky. Can Copilot simplify working with them?
Very much so. You can describe the pattern you need, like create a regex to validate an email address. Copilot will generate the complex pattern. Importantly, it usually provides an explanation of how the pattern works and sample code showing its usage.
Can it generate data needed for development or testing?
Yes, it can create sample data sets. For instance, a list of fictional user profiles or mappings between geographical regions. This can be useful for populating databases for testing. But again, remember to check this data. It might not be perfectly accurate or reflect real-world distributions.
And for users of the GitHub command line interface?
Copilot integration exists there too. Within the GitHub CLI, you can ask Copilot to suggest commands. You can type something like Copilot suggest, create a new repository, and it will give you the command and explain it.
Now let's look at Chapter 9. Copilot's integration directly within the GitHub website and platform. How does it work there?
Within GitHub itself, Copilot provides an assistive chat. This appears on repository pages, pull requests, and issues. You can ask questions about the repository, like summarize this project's main goals. It analyzes the code base and documentation to provide a summary, which is very helpful for quickly understanding a new project.
That sounds useful for onboarding. Can it help during the code contribution workflow?
Yes, it integrates into the workflow. If GitHub's code scanning finds vulnerabilities, Copilot can help create issues for them. There's also a feature called Copilot Autofix, which attempts to automatically generate code changes to fix certain detected issues. You review and apply the fix.
And for pull requests, where code changes are reviewed?
Copilot can be involved here too. You can ask it to summarize the changes in a pull request, generating a description for you. It can also act somewhat like a reviewer, providing automated comments or feedback on the code changes within the pull request itself.
So it's streamlining several steps in the typical GitHub process.
It aims to. It can help generate the pull request description, offer explanations for specific lines of code changed, summarize complex issues, all designed to make the process of contributing, reviewing, and understanding code on GitHub more efficient.
Finally, Chapter 10 discusses extending Copilot's capabilities further using extensions. What are these?
Extensions allow you to add new features or connect Copilot to other tools and services. There are two main kinds described. Copilot extensions, which work broadly wherever Copilot chat is available, like IDEs and GitHub.com, and VS Code extensions for Copilot, which are built specifically for the Visual Studio Code editor and use its unique APIs.
What's the practical difference in how they operate or are set up?
Copilot extensions generally act like adding new skills. They often require a companion GitHub app to handle permissions and communication with external services. VS Code extensions integrate more deeply with the editor itself. They don't need a separate GitHub app, but are limited to functioning only within VS Code.
Can we find extensions that others have built?
Yes, the GitHub Marketplace is the place to find and install available extensions. You might find extensions that help with Docker, or allow Copilot to query specific databases, or even perform web searches to get current information.
So we can add capabilities created by others. Is it possible to build our own custom extensions?
It is possible. The book provides guidance on building your own extensions. These could be agents capable of more complex multi-step tasks, like generating entire project scaffolds. Or they could be simpler skill sets focused on a specific task, like fetching information from an internal company API.
So you can tailor Copilot to very specific needs by building these extensions.
Exactly. It allows you to equip Copilot with specialized knowledge or tools relevant to your particular domain, team, or workflow, making it an even more powerful assistant.
We have certainly covered a lot of ground regarding GitHub Copilot. It's evidently a very capable tool, impacting many parts of the software development lifecycle.
Reflecting on Brent Laster's book, Learning GitHub Copilot, it's clear AI like this offers significant potential. It can help with coding, testing, documentation, and project management. However, the most important point, emphasized throughout, is the need for careful review. You must always validate Copilot's output. It's an assistant. The developer retains full responsibility for the final code.
We hope this overview has given you a solid understanding of GitHub Copilot's functionality. To gain deeper knowledge and practical skill, we definitely recommend reading the full book Learning GitHub Copilot by Brent Laster. It offers far more detail and examples.
Perhaps leave yourself with this thought. How can you best integrate this tool into your workflow? How can you use it to enhance your productivity and code quality while always maintaining that critical human oversight? Consider how Copilot can assist you, thoughtfully applied, in your day-to-day development work.